All right, so this is a pretty good group. Bill tells me that this is typically the size of the group you guys have. Oh, maybe that's not so true.
This may be more than we've ever had.
Oh, nevertheless, this is a pretty active user group, I think, even if you're half this number of people. So I think that's pretty cool. How many people here are kind of familiar with Nebraska Global? You know what we do, just try to get a sense of that. Okay, one thing I probably should clip a little bit is this Don't Panic Labs Nebraska Global thing, because sometimes that causes some. And can everybody hear me okay?
Yeah.
I'll have a hard time standing behind this. So Nebraska Global is the parent company of a lot of different companies, one of which is Don't Panic Labs. And so Don't Panic Labs is a lot of our product development team resides within that organization. They do a lot of development both inside the company, but also they do a lot of contract product development outside the company as well. So it was originally developed, that whole moniker, Don't Panic Labs, was originally developed by arch rival for us, because we thought if we went out and tried to recruit, young people into this company, that Nebraska Global sounded a little too corporate. And so we thought Don't Panic Labs is maybe a little more vibrant and interesting, things like that. So they're all one and the same. Don't Panic Labs, we use that term a lot when we're talking specifically about product development. So today, or tonight, I am going to just my goal is to just give you a little bit of insight on how we approach product development here at Nebraska Global and Don't Panic Labs. And so I've got about 30 slides or so, inclusive of some case studies, examples of a couple of the companies that you'll see today. One thing I think, one mantra, and we have a few mantras, is that we really do value simplicity here. We're really striving to make things as simple, repeatable as possible, and that's all up and down the stack and all across the different processes and roles. The other thing is I really like quotes, so you see a few quotes here as well. All right, I got to go the right way. Okay, so Nebraska Global was formed in 2010. We're a little over 5 years old. There was about a half dozen of us that got together. Actually, it was myself and Steve Keene and Patrick Smith who really kind of spent a year kind of formulating the idea and what we thought the mission for Nebraska Global would be. And then we formed that in April of 2010. That original group of 10 or 12 people that were involved with Steve, me, and Patrick, we've been together for a while. There's a lot of gray-haired people in that group. And so we had a lot of experience writing software. And some of that software was good, and we had some successes. I think by and large, we all of us felt like there was a better way to do it, and that's what I'm going to talk about here tonight. Nebraska Global is a bit of a unique model. Some of us had some experience working for startups where it's kind of a traditional, you're a founder, but you need money, so you go talk to VCs, pitch them, they give you money, sometimes they help in your network and whatnot. That was really a grind, because it felt like we were on this perpetual fundraising mission, which is still the case, I think. And we wanted to do something a little bit different. We wanted to kind of collapse that model. So we went out without a product or anything, and I owe this all to Steve Keene, because he is very charismatic and can sell anything. We went out, and we raised a little over $37 million from individual Nebraska investors who wanted to invest in our ability to build software companies in Nebraska. And so that was the main part of that. And part of that selling point was to try to create opportunities for young folks in this state to participate in developing these companies. So our idea was this kind of a chain reaction, if you will. We would contribute to creating an ecosystem both by building companies, but also training people that might go off, maybe even leave Nebraska Global and build their own companies. So that was our unique model. And like I said, that core group had been together for a lot of years already, so we had a pretty good rapport. So when we started Nebraska Global, me and the rest of the product development people got together and said, okay, this is a unique opportunity. We're not encumbered by any existing code base or anything like this. We know we want to build a lot of different products, and we know those products are going to be challenging to build. We were going to tackle some complex systems, so we needed to do things differently. And we were strongly motivated by a couple different groups of factors. One of them is something that I think anybody here who's spent any time writing software has probably experienced, and that is just kind of the general chaos that seems to accompany a lot of software that's being developed today. We, the folks who started Nebraska Global, had lived in this environment, and we felt strongly that this stuff wasn't necessary. That we often talk now about, we talk about the ilities, maintainability, reliability. Chad Michael, one of our developers, came up with this notion of funability. What are those things that are inherent to your process and design that continue to make it fun to write software? Because we didn't find any of these things fun, and we felt like there was a way to get around that. The second set of motivations were related to our unique model. We're building startups, okay? So we need our engineers to be incredibly productive as possible, because even though we had this fund, we were just spending $30 million at 12 people to build software. We were managing it like a VC fund. The other thing that's unusual is that we formed this product development team to be what we called an elastic resource. So the idea behind that is we built up a pretty good sized product development team right off the bat without a product to develop. And the idea then was, as these companies were identified or these opportunities were identified, and we decided, hey, we want to build that, then we would put as many resources as we could on that to get to that MVP as quickly as possible. Whereas, like maybe a traditional startup, you might be starved for resources for a while, and you might have to kind of limp along, or maybe you only got 2 people. But if we thought 6 people could get us there faster, we'd put 6 people on it. Once we got to that point, we would maybe downsize that a little bit and move those people over to another project. We're talking about software products that are in a variety of different problem domains. So we knew engineers were going to be moving around between these different projects. So we had to be consistent across all of them. There had to be, a consistent way from the process to the design to how we were testing. All that had to be consistent so that we could move these people around. And even if they didn't understand the problem domain, they didn't understand strength and conditioning, they could look at the code base and say, oh, I understand this though. I understand how this is designed and what all the different roles of the software are. I understand how the tempo, the scrum is going to be, the iteration time, and all that stuff. So then the other part was we're developing people. So we were hiring a lot of young engineers. We had not historically hired kids out of college. This is the first time we were hiring people out of college to work as software developers in our group, and we felt, profound responsibility to make sure we were giving them a great experience and they were learning to write software the way I think it's intended to be written. So we kind of boiled some of this stuff down into, I guess, what we'll call core values. And those fall into 6 categories. I mentioned we were going to be building complex software. If we were going to build software that was analogous to some structure to hide my trash cans at the end of my driveway, I might be able to just kind of draw that up on a napkin. But if I'm building a house, I'm not going to get by with some drawing on a napkin. We're talking about building houses, so we need to have a plan. And a lot of this kind of speaks back to my own personal background. I'm not a trained computer scientist or software engineer. My background is electrical engineering. And so I'm always reaching back to those things that I draw from more of my engineering experience that, for me, kind of makes sense even within a software development community. The other thing is, we all know software is changing a lot. I mean, that's a lot of why the Agile processes came into place, right? Because we can't predict what the software requirements are going to be, and that we gain insights through development in terms of what the design should be, what the customers want, all that. So our plan needs to accommodate the fact that change is inevitable and to not create something that's going to be resistant to change. The other thing, and this is more of an engineering type approach to this, but don't treat every new problem you come up with as unique. Let's try to leverage proven patterns and designs as we're developing and designing our software. And don't treat every project as the same type of project. So, the attributes of that project might dictate that the process for managing that project should be different than what your normal process is. So we like to think of our project management process, our Agile processes, as being adaptive, and to right-size those and to select those activities that make sense for this project that might not make sense for another one. And then in the experience that those original product development founders had that was shared, we had a definite segregation of roles between software development and QA. And we had a one-to-one relationship pretty much between every developer. There was an associated QA person. And there was a couple problems with that. That QA group was ultimately the one responsible for finding all bugs. That's what they did. They found bugs. So they weren't doing a lot of performance testing or testing with customers. They were doing mostly finding bugs. And we know that that's not the best way to do defect detection. We know that the body of knowledge of computer science tells us that a layered approach to software quality is a better approach. And we wanted to push that responsibility for quality back on the developer. So that's the last two values we came up with there. So on top of that are maybe a couple of mantras. If it's not adding value, then we don't want to do it. This is something I really appreciate Todd Gunther talking about that. He really kind of forced us to enumerate what we value and why we value it. And if we don't value it, we stop doing it. And so whether it comes to the types of metrics we're collecting or what a particular part of our process, we're always questioning ourselves, okay, is this really helping us? And if not, let's stop doing that. And then, like I said, keep everything simple. We need to be able to communicate how we're doing things very quickly. We have interns here all the time. We expect them to be doing the things the way we do them. And if it's difficult for them to understand, then I think we probably are causing problems. And we also felt that if ultimately we focus on keeping our developers as productive as possible, then I think we're probably on the right path. All right, so how does this translate to our approach? So these values are kind of a synthesis of our own experience and knowledge in the industry and best practices that we've seen or we've done ourselves. And we know there were no silver bullets, and we were kind of by nature resistant to any sort of dogmatic devotion to any one way to doing things, because it just kind of implies that there's one solution to every problem. So the rest of this presentation is broken up to kind of talk about these 5 basic areas, kind of how we're organized, how we plan, how we design software, and that's probably the largest portion of this, and I'll get to the reason for that when we get to that. And then how we take a layered approach to quality, and a little bit about protecting developers' time. That'll be the last part of that. All right, so our organization, this planning portion, I think is probably very familiar to a lot of you guys. I don't think it differs too much from kind of what's being done in general in industry. We found that our team sizes, typically 4 to 6 engineers, is about the max we can have. If a product requires more engineers, they're typically divided into teams, and in most cases, we can logically divide those. So maybe we got the front-end development team, we've got the back-end services team, whatever. We're not just randomly dividing them. Project manager is the hub of our product development team. I have a whole chart coming up here devoted to how important that particular role is, but it's no accident I have them in the middle of the screen there, because they're the ones that kind of make everything happen. This team lead role, in the black circle there, the team lead, they are a developer, but that's a special role. It's not a title that happens to be a role a person has on the team. And the reason it's not a title is that we want to try to rotate some of these young people into that role and give them that experience. But that guy ultimately is the one who's making sure that the design integrity is maintained, that we're coaching and mentoring the folks that are on that team, basically making sure everybody is doing the right thing on the product development team. And we really work hard, and you'll see this as you walk through our office. I'm sure many of you have open floor plans and things like that. That'll be my next slide. But we try to really make sure that there's no friction and the ability to collaborate and communicate. So things flow freely. There's nobody gating information. A software engineer can go talk to the product manager if he needs to. We're not creating any sort of infrastructure there. We're really a very flat infrastructure. We really don't have anybody here who's a supervisor or a manager in their title. All these guys are accountable to the team. And that actually isn't something we had to mandate. I think it was kind of a byproduct of this organization. Many of you probably have experienced the same thing. It's not like we had to come in there and say, you guys now, you got to report to each other. You got to police your own team. It just kind of happens naturally if you don't have this outside manager or supervisor. They're very responsible. So the other thing here is this QA role. I have it on this chart, but some teams don't even have a QA person. We actually only have 2 people here in the company that have QA in their title, out of a product development team that's about 40 people. It's not to say that we don't value QA, or that we won't have QA on some of those teams eventually, but the role we want for QA is not defect detection. It is more of the regression test, or managing release to production, or interacting with, doing customer acceptance and evaluation, things like that. Things that I guess we kind of feel quality assurance should be doing other than defect detection. So I talked about this project manager role. We have 2 of them here. They're a shared resource, kind of that flex resource idea. And they handle all of our project management across all of our different companies and projects. And I call them force multipliers, because they really enable these teams to be super productive. Their primary responsibility is they're facilitating. They're making sure that we're following the selected process and procedures that we need for that project. But they do a heck of a lot of other stuff. And really what they do, especially for like the team lead, but also the developers themselves, they free them from having to retain all those details about the things that need to be done, or that we need to make sure we do this, even if it's related to their particular job, like making sure we do certain things at the point in time where we're going to be releasing, or just little details that might fall through the crack. They capture and retain and bring that information up at the right time. It's like magic. It's really cool. So I've worked with Todd Gunther since 2000, and I've been in about 5 companies since 2000, and he's been at every one with me because I'm just so dependent upon him in that role and what he does. So office layout. This is something I'm sure many of you have experienced, but it doesn't take much friction, I'll call it, before it starts impacting people's ability to collaborate. I mean, putting up a divider between groups of people can impact that. When we start off on the 3rd floor here, and Beehive was on the 3rd floor, and I've interacted with them quite a bit, especially early on. And then they grew to a point where we needed to put them up on the 4th floor, and it was like they were in a different state. It was like I didn't hardly see these guys anymore. Because you have so much access to the people around you that just moving somebody to a different floor, you wouldn't think that would make a difference, but it does. It makes a difference. So we're very conscious of that. Our solution here, and you'll see this, is we have very open floor plans. We have adjustable desks, which I thought was crazy when the guys came in and wanted adjustable desks. But one of the cool things I sat there, saw these guys using these adjustable desks. Right away, I saw that when somebody needed help, he raised his desk, 2 people came by, and they all gathered around it. It was none of this sliding chairs trying to get everybody around the desk. That was really cool. So I was a big fan of that right off the bat. We do have some breakout rooms. When we first came here, everybody had desktop machines. We just were concerned about kind of investing in mobile laptops. We were concerned about just the throughput of these machines and what we were getting for the money, so we bought desktop machines. I'd love to tell you that this works great, but there are some drawbacks. And one of them is sometimes it's hard to get away from the ambient discussions that are happening. Because this is an accurate picture, and you'll see what's up there. They're not on top of each other, but they're close enough that it's kind of easy to get drawn into conversations. So when we were having a bunch of construction here, we bought everybody noise canceling headphones. That's one of the things you get here if you come to work here. You get some noise canceling headphones. Part of that was because of the construction, but part of that was to try to help people kind of just disconnect from everything that's going on around them. And the other thing we've done is we are making more of a move to mobile computing. So especially like we started out with the Don't Panic Labs group, all of them have mobile computers. And I think that allows people to just get up and go out on their deck or go down to scooters, just kind of get away. So I think the combination of those things kind of mitigates that. So that's our organization. So how we plan. Again, this should be fairly familiar to you guys. We're heavily motivated to manage our product development through a prioritized list backlog of stories. The whole idea there is we want to kind of create predictable throughput on our development processes. One thing that might be a little bit different is we emphasize, and this may be kind of a bit nuanced, but we emphasize that story development is really the beginning of design. We want to make sure people are thinking about design or what the ultimate implementation is going to be as we're analyzing these stories, maybe decomposing these stories. It's not just a project management effort. This is part of the design. And I think it gets people a little more engaged in that process. It's very important that our plan enables this progression through a pipeline, which I've got listed up here, which is quite long. But many of our efforts are built through the same pipeline, especially a lot of the consulting stuff we do for contract product development. It's also important that this process and planning incorporates some risk reduction. So prioritization of stories, we might move stories up or prioritize them based upon risk. We might create spike releases to reduce risk. We incorporate that into it as well. So the story development, like I said, that's where design starts. This is primarily a collaboration between that product owner and our project managers, and then that team lead. We will bring in other developers into that as necessary. That's primarily the folks who are involved. More and more, we're using low-fidelity UI/UX wireframes to try to kind of validate some of the customer requirements of the user interfaces. And I think we found that also gives us additional insights into design requirements that may not be apparent just from a story. So I think before we didn't have anybody that was in UI/UX. Now we've got 3 people in UI/UX. That's all they do. So that's really been kind of a pleasant surprise. So this is maybe a little bit unusual too. But when we have a story, we're estimating stories in the backlog. I give you that's our kind of fixed bucket estimates there. If any story in the backlog is bigger than a week, an estimate, we will break that down to try to get it in under a week. Part of that is to, again, try to tease out some of the insights into the design and the requirements that a kind of a 4-week story is not going to really give you. The sooner we see some of these, implicit assumptions that are built into people's approach or view of what that story is, the sooner we can accommodate that in our design and in our project planning. So we break those down. When things are less than a week, I think we feel fairly comfortable that we kind of understand the scope. Maybe it ends up being 2 weeks, but if something's a 4-week story, it could be a 4-week story, or it could be a 3-month story. I think there's just a lot of uncertainty in there. So that's really what we're trying to do, is kind of reduce that uncertainty. So a lot of our projects, talking about like an MVP release, is going to be a multi-sprint release. We're working on something that we're going to release in a month or 2 months or something like that. So in that case, we take that scope of stories that we have in the backlog that we want to be in that release, and we allocate them to sprints. And we take into consideration people's availability, who we want working on what, some of those risk reduction things. Basically just kind of mapping out what we think this is going to look like. And that gives us some idea of how long we think it's going to take. Because I'd love to live in a world where we don't have to give some people an idea of when something's going to be available, but I don't know about you guys, I don't live in that world. And I think that's a fair question that people should be asking is, when do you think this is going to be available? So this is one thing that gives us. But I think it also gives us this visibility into the rationale and kind of the timing and how we're attacking some of these problems. But again, this is a plan. It's not the law. We don't. If we had something planned for sprint 6 of this release, that obviously can change by the time we get to sprint 6. But it is a good starting point. We do have kind of multiple cadences, though. The multi-sprint release plan is one, but sometimes, we're also in kind of a maintenance development mode, especially after we've got through these major releases. And in that case, we tend to use more of a Kanban model, where, and I should say, many of our, maybe it says on here, our sprints are typically 1 week. We toyed around with that a little bit, but our sprints are 1 week, and some of our teams are actually doing releases weekly, which is probably as frequent as we're doing releases. So when we're kind of in this maintenance development mode, they're just pulling things off the backlog, whether they're minor enhancements or small features or maybe a bug or something like that, and they'll just get in as many as they can into that. And some of these teams, they ebb back and forth between these two, multi-release versus more Kanban model. Sometimes it's happening at the same time. And it just works. I love how that it just doesn't get in the way. It's just such a natural way for us to kind of maintain a rhythm, and people they go back and forth with that pretty easily. All right, so that was planning. So design. So I wish design was this easy. I wish I could find who actually said it too, but many of you have probably seen this quote. But I think if people thought about this, they would be more careful about how they design their software. I know I would. So there's a big section. This is the biggest section I have. It's probably, I don't know, it's probably 8 or 9 slides. The first part is more motivation. And the reason I'm emphasizing this here is because this was the biggest change from what we had previously done. We've been doing some Agile stuff, or at least planning before Nebraska Global, but this is where we made the biggest change. And so there's, and the reason I kind of want to emphasize this here, it's news motivation, is because I think this is also the area where, by and large, most software teams are really, I wouldn't say necessarily failing, but this is where the struggle is, whether they realize it or not. And so just to get on my soapbox a little bit, anybody here who's been through a computer science or computer engineering program likely did not have a single class devoted to software design. They had a lot of fundamental classes that were related to the principles of computer science and things like that, but they probably didn't have a class that was totally devoted to what are good design criteria, good design patterns, and I think that's awful. I can't believe we're sending people out. If you give them a complex system, who knows how they're going to be running? It's really up to them to kind of learn that on their own, or to attach themselves to somebody who's been doing this for 20 or 30 years and has somehow developed a coherent strategy for how to design software that's maintainable and has a long life. So this is really a big deal to us, and something we spend a lot of time just not only talking about to ourselves and trying to refine this, but educating people in general on kind of at least our approach to this. So what are we talking about when I'm talking about software design? Well, sometimes you hear things like software architecture, software design, high-level design versus top-level design. Software architecture is kind of really, that means many things to many people, so that's why I don't use that. Well, I'm not talking about this. I bring this up because if you, down at breaks, when we're asking people to give us your software design or your software architecture, this is what we get, which literally they could have just gone and clicked off, done a web search, grabbed the image and put it on there. Because we're always getting these client tier, services layer, data access, database. That's not what I'm talking about. That's like saying, okay, I'm going to build a house, and this is my plan. This is all I need to build my house. So that's definitely not what I'm talking about. What we need is a design that provides some structure here, right? So that we can maintain a sense of conceptual integrity of our design. And I'll get into that a little bit on the next page. But this is a representation of a variety of different architectural designs, or civil engineering designs. And it's the same building, but it's different views, right? So here's a plan view with dimensions looking down on it. Here's an elevation view. Here's an electrical layout. Here's some details of some particular interfaces between various portions of the company. If any of you have ever seen a set of blueprints for a building, it's page after page after page of different blueprints, of different details of different components. And if you're building complex systems, we need that too, right? We need to have some sort of a framework for how we're going to make decisions. So this is more relevant to us. This is, here we have a static design here, which is probably more akin to that first one, the end-tier design. This is broken out by individual classes, services. And here's something that shows interaction between these classes and services. Over here is an allocation of those classes and services to different processes. So those are all going to be valuable decisions and kind of guides for our development team as they're progressing. Again, it's on their plan. It doesn't mean that it's not going to change, but now we have a starting point. Okay, so this conceptual integrity. So the idea here is that we want the design to conform to a single set of principles and criteria, so we don't just have chaos. All right, because I have a quote here from Fred Brooks that he made in 1975. So Fred Brooks wrote the Mythical Man Month. He also wrote a bunch of essays on design. So he argues that he would rather have a system that has flaws, but has conceptual design integrity, than a perfect system that has is built with a lot of uncoordinated design ideas. The whole idea here is that, yeah, it may work better, but man, over time it's going to be problematic. We don't just write software once and put it on a shelf and that's it, we're done. A lot of that development is going on to revise that software and change that software. So how do we lose conceptual integrity? Well, we might start with a plan, but we don't control it. We don't maintain it. You have to be a good steward of that. You have to continue to keep it from wandering off the path. Or you could just decide, I don't need a plan, and developers will just make design decisions as they're implementing the code. And that happens a lot. I think probably that second one is what happens mostly, because the companies I've been involved with, this formal design process is not something that is typically done. So the result will be these independent and uncoordinated ideas. Okay, so what happens if we lose conceptual integrity? Many of you have probably heard this notion of software rot. It's fine in version 1, version 2, now it's starting to be painful to make changes, and version 3, I'm worried that the change I'm making might break something way over here, and by the way, I'd get into some of these codes, I have no idea how it works, so I'm just trying to build a firewall around this thing. So yeah, there's a lot, that's the chaos that we want to try to avoid. That's when we lose the funability of software. And there's any number, this list could probably go on, and anybody here who's been on a project for any number of years has probably felt that pain. Another way to look at this is something Martin Fowler came up with. And Martin Fowler is he's a big writer and author, big writer on patterns especially. He came up with this design stamina hypothesis. A conjecture, because it really can't be proven or anything like that, but I think intuitively we probably all understand what's going on here. And basically what he's saying is, yeah, there's probably a point, if you have no design, where there may be a window here where you could probably forego some design quality and maybe get features built faster. So we got cumulative functionality here over time. So that's what this is really relating here. But at some point, there's going to be a crossover here, this design payoff line, where the weight of all that technical debt is going to start bogging you down, and you're not going to be able to create those features as quickly as you were. Okay, and at that point, that's when the good design really starts paying off, and he even shows us being exponential improvement. So the interesting thing is, this design payoff line, he feels, and I would really agree with him, that point is probably weeks and not months. That you are very quickly, if you're writing any amount of code or have any sort of a team size, you are quickly crossing that line where you have now, you're not going to experience that benefit, that fast to market sort of benefit of ignoring design quality. So I think this is a really good diagram that kind of illustrates that. There's a lot of data to support this as well. This chart, this is from Steve McConnell's Code Complete. This is really representing kind of the cost of various activities over time, how expensive it is relatively to fix those defects later in the cycle. And I just want you to pay attention to the architectural or software design element. Very quickly, once we get into system tests or, heaven forbid, post-release, those decisions that you didn't make or made poorly during the design phase are incredibly expensive to fix. All right, so enough of the motivation now. How do we do it? So, like I said, we have a formal design process that we have in place here. It's totally fed by the story development. So that's how we go about this. And we're also trying to adhere to some very common design principles, again, things we have not made up. The notion of information hiding and design for change, which were principles that were developed in software and computer science back in the 70s. And they kind of led to things like encapsulations, things like that. Really trying to maximize the cohesiveness of our classes or services, not making these big God classes. Really minimizing, you can't eliminate coupling in a system, but minimizing that coupling. We're getting the right kind of coupling. We don't want to functionally couple our classes, but maybe we want to couple them through exchanging of just primitive data and things like that. And we also favor a closed versus an open architecture. What I mean by that is, there's nothing in your programming environment that really restricts any class from calling any other class. You can create boundaries and things like that to protect that. But what we have is a convention that says there are firm rules about who can interact with who. And that really helps with maintaining kind of avoiding this coupling that will typically come from that. So really try to minimize complexity here, design complexity. We have this I often talk about, hey, Cleverness is complexity. Let's avoid the cleverness unless it's absolutely necessary. And that happens a lot. People really, there's a lot of people who are really kind of driven by just trying to find what is that kind of novel, unique solution to this problem. Somebody else is going to have to read that code later on down the road and maintain it. That's not going to help. The other thing I often talk about is trying to design a system so that when changes do occur, we want to minimize the field of view of that developer so that he only has to understand this amount of the system to be able to make that change, not this amount of the system. So really minimizing field of view. Designing for testability. We've done a lot of this before, but this time we said we will absolutely, and this is kind of related to kind of putting accountability on the developers for the design and code quality, is to demand automated tests at a class level or a unit level for our systems. And then coming up with a consistent design methodology. So going through this process is going to be easy and familiar for people as they move between these teams and as we do these new things. So fortunately, we didn't have to invent the basic foundation of how we are designing software. We're using something that was developed by Jawal Louie at iDesign called the method. If you go out and Google the Zen of architecture, you'll see a 1-hour presentation where he talks about this. And actually, he's a fascinating guy to listen to. He's one of 4 or 5 Microsoft legends out there, and he helped develop and design the Windows communication framework, which is a lot of plumbing for web services out there that is being used today. So the whole idea behind this thing is there are very simplified conventions and rules to this system, and we have found that this whole thing applies to all of our software design, whether it's a desktop application or distributed services, interior architecture, doesn't matter. Mobile apps, we've been able to apply the same design methodology to all of that. I think we've kind of adopted and hybridized this thing a little bit because I think he was targeting enterprise IT architecture, big distributed services where you're building a system, think AWS or something like that. But it translates down to a small team of 2 or 3 guys designing software as well. So we treat every class as if it was a service. And even if everything's running in process, we separate our data from our behavior. So classes and services have behavior, and they exchange data contracts. At its simplest form, that's really what we're doing. And this methodology also provides those multiple views, like I was talking about, like the project plans for our house. You've got to have all those different views. This one does the same. So I have tons of charts about that too, but I would just say if you're interested in that, go Google Zen of architecture. So that's software design. So quality. This is also information I got from Steve McConnell's Code Complete. It's data. It's not data from studies he did. I mean, that book is all just a synthesis of a bunch of different research topics and papers written on computer science. But this is actually from a bunch of studies that we're testing. We're trying to determine what is the relative effectiveness of various defect detection techniques. And the message to take from here is that no one method is really going to get you where you want to be. It's not real unrealistic to think that you might detect 90% of your bugs before they go into production. And that's actually, I think, a pretty good goal. It should not be 100%. If you're building a flight control system for an airliner, it probably needs to be closer to 100%. But to go from 90 to 100, it's an exponential growth and effort to do that. It just doesn't make sense for most software by and large. But to get to 90%, you're going to have to do a combination of these things, and that is really what computer science tells us is the right approach to quality is a layered approach. So we have a layered approach here. We do pair programming. We have unit tests I was talking about. We do GitHub pull requests. That lead engineer, he reviews every single pull request. The pull request, for those not familiar with GitHub, basically I can branch off a source code, I make all my changes, and then I submit that branch to be merged into our master branch through what's called a pull request. It doesn't automatically go into that master branch. It goes through a convention where somebody is reviewing it and merging it on your behalf. But that creates that code review. Every bit of code that's going into our master branch is code reviewed. It's code reviewed by the guy who's responsible for maintaining conceptual integrity of the design. So he's going to catch that there. If somebody's doing something wrong, or if somebody's violating one of our conventions, he can catch it there before it gets into production. And then we have a lot of regression tests and integration tests. We try to automate those as much as possible. We do have manual testing. We have not solved the problem of UI testing. Or we have also not solved the problem of all this business logic that's getting written in JavaScript that scares the heck out of me. So, what just came up there? Oh yeah, so automation. We do leverage a lot of continuous integration tools, even though we're actually not doing continuous integration. Like I said, we're releasing on about a weekly basis. Is probably the fastest tempo we have there. So this is actually taken from our definitions of done. We actually have two. So one is for our sprints and one is for releases. And so this is activities on the left are activities that are within the development sprint, and these are ones on the right really fall outside of that. That's really kind of where QA gets involved more. And so you can see that we have 6 of these things that are totally related to quality, obviously. All right, so that's our layered approach to quality. So the last thing I want to talk about is protecting developers' time. A guy named Paul Graham, who was one of the founders of Y Combinator, which is an incubator out in Silicon Valley, wrote an essay, I don't know, like 7 or 8 years ago, called The Maker versus Manager's Schedule. And in there he talked about how a manager's schedule is one full of meetings, where they're jumping from context to context, and changing meetings. They're not really getting deep on anything. A maker's schedule is kind of the opposite of that. A maker, somebody who's in the maker world, needs large blocks of uninterrupted time to get into the problem. To get, it may take an hour or two for somebody who is in kind of an artistic endeavor or trying to solve a problem to really start getting ahead of steam and really start to be productive. And his whole point was that if you force a maker's schedule or a manager's schedule on a maker, you're not allowing that dynamic to happen. So his big argument was you've got to find a way to allow your developers to have a maker's schedule. And so really this is a big challenge for our project managers because they have all the stand-ups and we have meetings that are required for people to be at. But a few years ago we said, okay, we are going to set 10 a.m. as the latest time we can have meetings that will involve any of the development team. And after that, it's going to have a good reason why you're going to do that. And it was tough, and it still requires a lot of management amongst those people and flexibility of those teams. Well, by and large, we have achieved that. I have here, on the left is actually taken from my schedule, which is typical. So I am a manager's schedule, so I'm not having any fun. On the right here, I took that that's a snapshot from one of our developers. In fact, it took me 2 or 3 tries to find a developer who had something in the afternoon. So I didn't want to throw some up here that had nothing in the afternoon. But there was a couple of people I looked at, they literally had nothing on their calendar after about 10 a.m. And I think that has had a huge impact on not only our productivity, but also the funability, how people are enjoying their work. So I'd strongly encourage you, if you aren't familiar with this concept, to take a look at that. And if you want to learn more, talk to folks who've experienced that, or talk to a project manager how you make something like that work, I would strongly encourage you to do that. Because I think if there's one thing that might be easy to adopt, I think doing that will increase your productivity if you're not doing it already. All right. So I want to take the last part of this and just give you a real quick overview, kind of how this kind of some of the results of this whole approach on a couple of products that both of which you'll see tonight. The first one is Elite Form. Elite Form, we did when the Kinect for Xbox 360 came out, had a $100 3-dimensional high-resolution depth camera in it, and we were like, holy crap! There's all kinds of things you can do with that. Now these cameras that were thousands of dollars now are $100. What can we build with this? And so the first thing we did, unfortunately, we jumped on a bunch of things that the Windows Kinect SDK was not going to help us with. So we picked all these different things that we had to write our own algorithms. We actually had 2 PhD mathematicians working on this type of stuff. The first one we did, though, we started with, was a tool that allowed us to track athletes doing lifts at these racks. So think of the football team down in Nebraska. It would track the velocity and position of that bar. It turns out velocity of a lift for a lot of strength trainers is an incredibly important metric. It doesn't matter how much weight you lift, it matters how much weight you lift within a narrow velocity band. And this is something that the Russians figured out, or the Soviets, I guess, figured out back in the 70s and 80s. And they have a lot of data to support this. So there's a lot of strength trainers out there like, if I could just coach the strength training to velocity, we'd be in a different place. So that's exactly what Elite Form does. I mean, it's got more complexity and solves more problems than that, but that's really the main differentiator. So Elite Form is in use by dozens of teams and military units, both amateur and professional, on multiple continents. It works really well. 10 months from the start of that to where it was in use during the spring of 2012 by the Nebraska Global team. And they used it as part of their strength and conditioning program during spring practice. It was 10 people that built it, 8 developers and 2 mathematicians, and literally we started from drivers for the camera, essentially is what we had, and built the system up from that. And so in the last month we've had 1 hotfix with that system. Like I said, it's been used by a lot of different teams. So, and what's interesting, on top of, during that whole time, we also developed a whole suite of automation tools that takes a bunch of videos that we collected that are tagged that we can run our algorithms against to validate that whatever changes we might make in the algorithms, this is kind of a qualitative thing, right? This is kind of an analog as opposed to this binary, it works or doesn't. It's like it works this well. So we had some accuracy metrics and things like that. So we can tweak the algorithms, and we have this whole cluster that runs all these algorithms against these videos overnight, or in a few hours it tells us exactly what the changes were to our performance on that. So that's Elite Form. Beehive is another one. That'll be on the 4th floor. Beehive is a platform we developed to be able to manage things that have properties and location and events that you do to them. So that's as abstract as I could probably make it. The first project we did was called Beehive City, and it's designed to really unlock all the data and information and workflows for managing city infrastructure for the knowledge workers, especially for small and medium-sized towns. So that's who's targeted for this. Traditionally, they didn't have access to all this information. They had to go to somebody and say, hey, can you give me a map of all the fire hydrants? Okay, now can you run me a report the last time they were serviced? And they had to go to somebody to do that. Now, they just log into Beehive and they do that themselves, and they add all the data. So there's also, as a platform though, it's been used for construction management, for Arbor Day uses it to give away trees, or to allow electric utilities to give away trees to their customers. And people can go in there and they can they find their house, they pick the tree, and they drag it around their property, and it tells them what the energy efficiency impact of that tree will be over the next 10 years or something like that. And then they can purchase. Another one is a fence estimation program. So it's a big problem with fence contractors. Every time somebody calls and says, hey, I may want a fence, they got to go out there, they measure it, they give them a quote, and they say, okay, thanks, that's more than I thought it was going to be, so I think I'm going to pass. So this lead development for fence companies is really cumbersome. So we built a system that's now being marketed by, I can't remember the name of the company. My salesman. To allow fence contractors to use this to point their customers to, say, yeah, go on there and kind of design your fence and get a rough quote. And if you're interested, we'll get you a more detailed quote. So it's really kind of a cool tool. So it's showing its extensibility to different problem domains or different markets. So lots of states, I don't remember how many states are used, or cities and states are using Beehive City. I'm guessing it's close to maybe 15 or 20.
That's 16 states.
16 states. All right. So it was 6 months from the time we started that till we had it running in Grand Island, which was one of our first clients. And that was 8 engineers and 1 QA. So over time, we've been able to kind of automate the configuration of this. Every city manages these things differently, so they all have their own configuration. And we have a system where we get all individual cities' data, and we run an update of the software if we were going to be released today against that and run tests against it to see if there's any problems against the whole spectrum of users on that platform. It all happens automatically. And they literally now, they do weekly unintended release. They literally do the release on Saturday at 7, and then everybody just walks away Monday morning. It works beautifully. A bit of a benefit here is that city public works workers don't work on weekends. So if they do have some time, if there's a problem. But it's really, they went from, think about how you hated some releases in your life. You know, these guys have really, they bought into this and done all the hard work to make sure they can get to a point where they really don't care when releases happen. And I think that's pretty cool. So that's Nebraska Global Product Development. This last page here, I'm listing a few of the kind of the influencers on us, and there's many of them. You know, we didn't invent, I don't feel like we invented any of this. We synthesized a lot of this. Okay, so, and I would point out that, you know, we're pretty active writing about a lot of the stuff we do. So if you're interested in the DPL newsletter, there's a link to Tiny URL, and I have my contact information in there. That's what I have. But take some questions. I don't know actually what the next step is. Anybody have any questions?
Yeah, there was a quality process on there that it was the highest one at 60%, but I hadn't heard that term before.
Was it desk checking?
Yeah.
That's you literally going through your code and reviewing it yourself. Yeah, I didn't know. I had to look that up when I first saw it too. I should probably change that. But yeah, that's the developer themselves spending time and saying, okay, have I got this right? So, yeah, it's very effective, by the way.
Yeah.
Surprise, surprise. Yeah.
You said you're an associate professor, right? And you also mentioned
Volunteer.
volunteer. Okay. I mean, you also mentioned that a lot of developers leave school not really knowing complex software design. Why do you think that is, and what needs to be done to fix that?
Man, I could talk a lot about that. So, I guess the best analogy I have is that a physicist and a civil or structural engineer take a lot of the same physics classes, right? But if you're going to build a bridge, are you going to ask a physicist to do it, or are you going to ask the civil engineer? You're probably going to have to ask the civil engineer, because whereas the physicist is building in order to learn about physics, an engineer is learning in order to build. So it's a different approach to teaching. What we have now in schools, we have computer science, which is a liberal arts degree. And I think they're doing their best, or it's an arts and science degree. They're doing their best to they recognize that they need to train people for both academics as well as industry. And I think they're doing the best they can. But they are naturally favoring the science side of computer science. And at the expense of really training people to be prepared to run industry. Now, the University of Nebraska, starting in the fall of 2016, is going to have a Bachelor's of Science in Software Engineering. There's only a handful of those in the country. And if you ask me, by and large, most of them are not, you can't really differentiate them very much from computer science. I really think they need to be very separate disciplines and taught quite differently. And one of the main missing components that some of these software engineering courses have is a lack of emphasis on design, applying that learning to complex problems and not just kind of more academic tools. If people here are familiar with the Race School has something, they have a 2-year capstone experience called Design Studio, and they are building projects for external companies. And they do it 2 years. And I think it's cool that they have Design Studio. I think the coolest thing is that they do it 2 years. Because you see the growth from that junior year to that senior year. They've been through this before. They felt some pain. You know, they're still coming out with a bit of a deficiency on software, a big deficiency on software design. But at least they're getting some context on that. So that was probably a long answer to that. But that, in general, that's what it is. I think that we're trying to serve two masters. You can't do that well. I think they're serving the computer science side of that pretty well, and they had to make a choice, I think.
You mentioned that design came after the stories were written. Can you describe kind of like the cycle between planning and execution, and how long did you devote to one?
Yeah. So, yeah, that's a good question. The question was, kind of how does this flow from story development into we're in sprints? How long is that? I will tell you that there's a lot of kind of this preparation, this slow burn preparation that might occur over time to kind of get to a point where, okay, we're ready to kind of devote people full time to getting us going. And depending on whether you have kind of UI, UX development that has to occur, sometimes that has to be sometimes that's a long lead item. But let's say we have spent the time developing and we've got a good backlog of stories, which I think that we're talking days, not weeks, to develop that. Days or a week or something like that. We really try to time box these efforts. When we get to that point, we get to this formal design phase, we absolutely time box that to a calendar week. It takes no longer than that. So we go through and develop all those different views, and we decompose all these stories into these kind of unique interactions of classes, and we know kind of what behaviors are going to be handled by which services in less than a week. And a couple of reasons for that. One is it really shouldn't take that long, okay, to get to good enough, which is really what we're looking for. We're not looking for the perfect design, because the perfect design doesn't exist, and we know it's going to change. We know that the as-built, or the final software, it will resemble in large part what the design is, but there's going to be changes as we develop more insights. So that takes a week. And so we plan for that in what we call an iteration 0, because that, along with setting up your environment and your build server, we've been guilty of, we would just go straight to iteration 1. We've got our iteration 1 planned out, so let's start going. And all of a sudden somebody's like, oh, well, we don't have the build server set up. Okay, well, you spent time doing, we spent that whole first week doing nothing but setting up infrastructure, and then we were a week behind on our sprint. So we have this notion of iteration 0 where we do a lot of the data modeling, we do a lot of the formal design process of the software design. We institute our build server, we get the solution set up, we get all these classes mapped in there, so when a developer starts on a brand new greenfield project, it's not a blank IDE. We've stubbed out all the interfaces, all the classes, all the data contracts that we know of, so that they kind of have the whole skeleton there. Is that what you're kind of alluding to, or? Yeah. Oh, okay. And I think our iteration planning is pretty efficient too. Like, we do that weekly. Some of you may have thought that 1 week there's a lot of overhead doing iteration planning every week. We actually started with 2 weeks, and we felt like 2 weeks was just too long. We didn't have real good visibility into progress we were making, and we went to 1 week. The reason we started with 2 weeks is we thought, do we want to do iteration planning every week? That seems like it's inefficient. We went back to 1 week, and I think we never looked back. I think we streamlined all that iteration planning or sprint planning so that it doesn't really take up as much time. It's kind of minimized.